All right, today we're going to look at Unit 2, Day 2. Got a couple of things to go here. We got two variable inequalities and absolute value equations that we're going to deal with. So let's look at the inequalities first. So we have four inequality signs that we need to look at. We got less than or equal to, greater than or equal to. So this chart's kind of designed where we kind of read across. So these guys go this way, as do these guys. Okay, so if it's less than, greater than, it's going to be a dashed line. If it's less than or equal to, greater than or equal to, it's going to be solid. Now if you read it this way, if it's less than or equal to, we're going to shade below. Greater than or equal to, we're going to shade above. Now the only way that works is if the y value is on the left, okay? The y value is on the left. So let me kind of get rid of all of this marking so you can kind of see the chart. Okay, the y has to be on the left for the shading to occur. All right, so let's see what happens. So here's our first example in that regard. So this is a linear inequality. You actually did this in Algebra 1, so hopefully that helps. Gotta get the y by itself, which it is. So this is gonna tell us two things. It's gonna be dashed. So a dashed line, this is linear. So dashed line, and we're gonna shade above because it's greater than. Okay, so dashed line, shade above. So this is a linear equation. The y-intercept is +1. The slope is 3/2, so up 3, right 2. If you go in reverse, down 3, left 2, down 3, left 2. So we're going to connect those dots, but before we connect them, we have to make sure it's a dashed line. Okay? Okay, so it's a dashed line. So that is not part of the solution set. Now, we need to shade above because it's greater than. Well, pick any point and go up. So that will show you that that's above. You know, this point, it's above. So we're going to shade all of this. So that's how we graph inequalities. So that shaded region, that blue region, every single one of those points is part of the solution set. Okay? Now you could also pick what we call a test point. For example, if we pick the point 30, if you do this, I would pick a point on one of the axes. That way one of the values is 0. So 30, you can pick that as a test point and plug it in. Replace the x with 3, replace the y with 0. So you would get 0 is greater than 3/2 times 3 plus 1, okay? And then 9/2 when you do the multiplication, and that will give you 11/2. Now, is 0 greater than 11/2? No, okay? So that's why that's Green's point there is not part of the solution set. So that would be false, so you would shade on the other side. All right, now here's an absolute value inequality. So again, the y is by itself. Okay, so look at your inequality sign. That tells us two things: solid and shade below. You must get the y value by itself to get those two guys. All right, now this is just a basic absolute value. It goes to the left 2, down 3. Okay, left 2, down 3. It opens down because it flips that x-axis. So our v is going to look like this. Okay, so hopefully that's not new. Now, it's going to be a solid line. So when we connect these points, it's going to be a solid line. Okay, so that takes care of that guy. Now we're going to shade below. So take, again, any point and go below it. You can take any point and go below it. So that means we're gonna shade all of this region. Now remember, this graph keeps going and going and going. The V will keep going down, and we're gonna shade everything below it. So again, the blue part there, that's your answer. Every single solution is part of that, let me say it again. Every point in there is part of your solution set. So that's how we graph inequalities. So now we're gonna solve some absolute value equations. Now the key here is we will generally get two solutions. Now here's why. If I were to ask you, give me a value that's 5 units away from 0, you could give me +5, you could give me -5. Okay, so absolute value is the distance from 0. All right, so here's our first example with absolute value equations. Now the first thing we need to consider is we need to get the absolute value portion by itself. This example, that's done for us. So what we're gonna do is set up two parts. Okay, the first part, you simply take the absolute value signs away. Okay, that will give us one answer. I should say possible answers, because you should always check your answers. So take your absolute value signs away. So we had the positive of what's inside, now we need the negative of what's inside. Okay, so it's the positive of what's inside, it's the negative of what's inside. Now you have your two equations, now you're gonna solve. Okay, so subtract your 15 both sides. Divide by -3. Okay, so there's one possible answer. Here we need to distribute the minus sign all the way through. Get your x by itself, so we're going to add 15 to both sides. And divide by 3. So here's our two possible answers. Now we should always plug them back in to check. So if you replace your x value and do the math, you're going to see that both of these work. But always get in the habit of checking your answer. Now, there's a couple things that you need to be careful with. So there's your two answers, x equals 3, x equals 7. Another way to represent this is with the funny brackets, if you will. This is not an ordered pair. Okay, that's the solution set, 3, 7. And then another thing we could do is graph. Now with, when we have x equals 3, x equals 7, there's no shading involved. We just put 2 points. And that is how you solve an absolute value equation. All right, let's try this one. Again, we're trying to solve for x. Now, we have to set up our two parts, but we can't do that yet until we get the absolute value part by itself. So we need to subtract 4. And then divide both sides by -2. That's the opposite of multiplication. You cannot multiply through the absolute value, so it's not like distributive property. You cannot distribute through the absolute values, what I'm trying to say there. So this is what we get. We got the absolute value of x plus 9 is equal to 9/2. Now we can set up our two parts, okay? So we're gonna say x plus 9 equals 9/2, or the opposite of x plus 9 equals 9/2. There's your two parts. So we're going to solve for x in each case. So here we subtract the 9. Now, because of the fraction on that right side, I'm going to disguise my 9 as 18/2. Okay, so that will get us a common denominator, and you can see we're going to end up with x equals -9/2. Here we're going to distribute the negative. We're going to add the 9. So again, because of the fraction over there, I'm going to change my 9 to 18/2. just solving. Hopefully you're pretty good with these equations once you get to this part. Just be careful with the fractions and so forth. Now, again, you should always get in the habit of checking your answers. Both of these work. Okay, so you can see we get -9 as one answer. We get -27 as our other answer. So we can represent that with this funny bracket, if you will. There's your two solutions. Okay, and we could also graph. So we have a number line here. Okay, so if it's an absolute value equation, you're just going to put two dots. So -27/2 is really -13.5, so roughly right there. -9 is -4.5, so roughly right there. Okay? So there you have it. All right, one last example. So this one is what we call an extraneous solution. This is why you should always, always, always check your answers. Now this one, whenever you see an X on that right side, this is where you really, really, really need to check your answer, okay? So that's kind of the giveaway that you really need to notice this one. So the absolute value is by itself, so we can set up our two parts. So the first part, just take your absolute value signs away. The second part, you do the opposite of what's inside. The opposite of what's inside is equal to that -4x minus 1. Okay, now solve in both cases. So here we have, the x's on both sides, so we need to get them together. I always like to bring my x's to the left side, so I'm going to do that. Okay, so add your 4 at that point and divide by 7. Now I'm not going to box this one off yet because potentially it might not work. Okay, so I'm just going to hold that thought there. So now over on the other one, you distribute first. Distribute your minus sign. Now we need to get our x's together. Remember, with equations, whatever you do to one side, you must do to the other. Okay, so there you have it. X equals -5 or x equals 3/7. Now, when you plug these back into the original equation, so you got to go all the way back to the original equation. The key here is when you plug this in here, this whole side needs to be greater than or equal to 0, right? Because the absolute value is always going to be 0 or positive. Now the -5 is real easy to check. -4 times -5 is 20, minus 1 is 19. So that's kind of a good indication that that's going to work. So that x equals -5 does work. The 3/7, however, does not work. So if I replace that x with 3/7 and multiply by -4, that will give us -12/7, and then minus the 1, it's still going to be minus. Okay, so what's going to happen here is this 3/7 is an extraneous solution. It's not going to work. The left side of the equation will not equal the right side of the equation. So we only get one solution here of -5. Okay, and if we look at it on a graph, it's just going to be one dot right there. However, remember, with absolute value equations, you will generally get two answers. Just like equations you did in Algebra 1, always check your answers. And that will conclude Unit 2, Day 2.